Ready? Let me make sure we're streaming. Okay, listen up. Alright, so today we're going to be talking about matrices, which is plural. Singular is matrix with an X. M-A-T-R-I-X, okay? Huh? I'm sure it was on in my house. Like, I don't really watch movies. Well, I don't care. Okay, so when you were in Algebra 1, you probably touched on matrices. And in Algebra 1, we do a little real basic matrix operations. And what we're going to do today, excuse me, what we're going to do today is also real basic matrix operations, okay? We're reviewing the basic stuff because we're going to use them for some harder things that in itself is not hard, but it will make things a little easier. Like, y'all know that whole solving systems thing? We can do it with a matrix, okay? Well, with a couple of matrices. So, first thing that we got to talk about is what they look like. So, a matrix is when you have just numbers inside two brackets like this. And these numbers are organized into rows, and the number of rows depend on how many rows you got. So, like, let's say we have 2 rows, okay? And then columns. So, let's say we have, like, 3 columns.
So is this one matrix?
Yeah, this is one matrix.
I remember.
So,
Each set of brackets is a matrix.
each set of brackets is a matrix, yes. And a matrix is, its dimensions is given by row by column. So however many rows you have by however many columns you have is the size of the matrix. So in this case, the way we have this one laid out, this would be a 2 by 3 matrix. 2 rows, 3 columns. Y'all with me so far? So on a matrix, you're just gonna have numbers. And I'm trying to use a matrix I'm already seeing, and I just realized I wrote down the wrong matrix, but it doesn't matter. Okay. So where did these numbers come from? I made them up. Okay? They're just numbers. This is just an example of what a matrix might look like, right? So it can have not negatives, it can have positives. 0 could be a number. Each one of those numbers represents some sort of data in the real world. Like in the real world, if you used a matrix, it would be representing data. It's like a table. That's all it is. Okay? Everybody with me so far? And each one of these locations, like every one of them, every one of those spots, every single one of them, and I'm going to do this all the way around, all of those, everyone, those are all called cells. So each one of those locations is a specific cell. And you talk about this cell based on its row and its column. So you would say like this 2 right here is in row 1, column 1. Right? This -5 is in row 2, column 3. You'll see how that works? Okay, now, what we're doing today, basic, is we're going to add and subtract matrices. And then we're going to multiply some matrices by a number. That's all we're going to do today. Real basic. But there's a few rules to it that you have to understand. Okay? You can only add or subtract a matrix, a set of matrices, if they're the same size. So if they're both 2 by 3, you can add and subtract them. If one's 2 by 3 and one's 3 by 2, can't do it. If you have a 1 by 4 matrix and a 2 by 3 matrix, you cannot add them or subtract them. Now, multiplication, which we're not going to do today, has a different set of rules. But just addition and subtraction, the only way you can do it is if they're the same size. Okay? So let's look at a few. So like if you look at number 1 right there, what size would this matrix be? How many rows? 1 row. How many columns? 2. 1 by 2. What size is this one? 1 by 2. So we can add these together. Now, when you add them, I do not know. I'm going to get a drink. I don't know what's going on. Hey, guys, I need to get this set down. Okay, so if we're going to add those two that and I'm going to write them down here. Negative 4, 4, 5. So if you can get a drink if you need one. So if we're going to add these two together, then all you do is add the numbers that are in the same cells in the two matrices. So like this 5 and this 4 in the same cell. So we just add them together. So 5 plus 4 would be 9. And then you add these two. So negative 4 plus 5 would be 1. And that's your answer. Yeah. Told y'all this will be easy. Okay. Huh? That's it. Good question. So, what if you're subtracting? So, exact same thing. The only difference is you subtract them instead of add them, right? So, we would do 8 minus 0. Now, what would 8 minus 0 be? 8. Negative 1 minus 6. Negative 7. 3 minus negative 7. 10. Good. Negative 1 minus 2. And that's our answer. Like I said, it's exactly the same. You just subtract instead of add. Now, for some of you, you may need to write those down. Like it may be easier for you if you write them down rather than just doing it in your head. And that's fine. Do it however works best for you. What if I had these two here? Why not? Okay. This is 1 row by 3 columns. This is 3 rows by 1 column. You cannot add these. So, and this is where people will mess up because they're like, oh, well, I'll just add the 3 and the 4, the 1 and the negative 1 and the 6 and the 2. But they're not in the same place, right? This negative 1 is row 2, column 1. This is row 1, column 2. Y'all see how those are in different locations? You cannot add those together. So this, your answer would just be impossible. You could, I mean, if you added the 3 and the 4 because they're both column 1, row 1, but then you can't do anything else. So you're just stuck. Like, you got nothing, right? I mean, technically, what you could do is write out this great old big 3x3 thing.
Or we can just leave it as impossible.
Okay. Y'all, are y'all 3-year-olds? Come on.
Yes.
Okay, so can you add these together? Yes, they're both 2x3s, right? This has 2 rows, 3 columns. This has 2 rows, 3 columns. So you would just add row 1, column 1 to row 1, column 1. Row 2, column 1 to row 2, column 1. Just like we did on the smaller ones, they're just a little bit bigger. That's the only difference. So if we're adding them together, right? So 5 and 9, 4 and 1, 9, -1, 6 and 8, 2 and 2, -6 and 4, and that's our answer. It's not hard, right? Now, we're going to take it up slightly, not even hard again. Still not hard, okay? Still not hard.
Oh my gosh. I think you put that 3 wrong. I think you should like put it inside.
So, all you're going to do, all this is it says 3 times this matrix. That means you just multiply everything inside this matrix times 3. Okay? So you would do 3 times 9, and you get 27. 3 times 4, and you get 12. 3 times -3, and you get... Right? And sometimes we might combine the 2 things together. So, like, you might have... I don't know why I'm copying off problems. Because, like, literally I could make up any numbers. And it would not matter.
It just makes more easier with mine.
So sometimes you might have something like this, right? Yeah.
So on the quiz, we have multiple rows.
No, you'll multiply the whole thing by one thing. Mm-hmm. Okay, so in this case, what would you do first? You multiply first. Just like as if these were just numbers, right? Multiplication comes first. You're still doing the correct order of operations. You're still doing the correct order of operations, so we multiply first, right? So you would multiply everything here by -2. So it's going to give us 4. Right? And then we add 1 to all of them. So it's going to be... And that's our answer. And that's it. Okay? Now, I do want to show you, and really, like, I'm straight up with you. You know, I'll always tell you exactly what I really think. There is 0 reason why you would ever need to plug adding or subtracting matrices into a calculator. It will take you longer to plug it in than it would to just do the math. Okay? For real. Like, it will take you longer. In class. In a real world situation, you may have like some decimals and numbers and stuff where a calculator would be useful, right?
What are they used for?
Organizing data. I'll show you in a minute. Okay, so if you hit the green alpha button on your calculator,
Gotta turn it on.
it's on. And then you hit zoom.
Oh, it doesn't look like it.
It's the lights hitting it just wrong. You get this. So this alpha zoom is what that is. Alpha zoom. And before you can put the numbers in, you have to tell the calculator what size your matrix is. So to do that, you just use your arrows, right? And you arrow over to whatever location your size is.
What if it would take a long time?
And you hit enter, right?
That would take a long time. What if it's more than 6?
You can't do it. I guess. I don't know what I just hit. Yep, 6 is the biggest. 6 by 6. If you're doing something that's bigger than 6 by 6, you're using a spreadsheet for that.
That sounds really fun.
You're not using a calculator. Okay. So let's say we have this 3 by 2 matrix, and we go down and say, oh, what did I just do? We don't want to do that. Let's do a 3 by 2. And we say, okay, it looks like this. Now you just type in your numbers. I'm just going to make up crap, okay? Why did I do that? I have no clue. All right, so there it is. And then you would put your operation, whatever your operation is, right? Let's say plus. And then alpha zoom. And you have to, of course, you can only add them together if they're the same size. So you get the same size.
What if you do it with different size of the calculator?
Yeah, I think it'll say error.
Do one by one. Do it one by one.
Okay. See where it says dim?
Yep.
You know what that stands for?
Dimension.
Dimension. Dimension mismatch means that your dimensions are wrong. Anytime you see dimension mismatch, that means that you've got things that aren't lining up. So, like, sometimes if you do a list on the calculator, you have like X's and Y's, and you try to do something with them, you'll see dim mismatch, and it's because you have too many X's or too many Y's. Okay. So, y'all get this, right? And like I said, literally no reason to use this for these. It will take you longer typing them in than it would to just do the math. But when we do some harder stuff with it, having that knowledge may be helpful for you. And I wanted to go ahead and show it to you. Okay? Now, when would you use these? I'm going to show you. I'm going to show you where you would use these.
Organizing data. Where did it be one?
I'm going to do it.
We only do one problem.
I'm going to make that.
Oh, 3 problems.
Good try, though.
4.
20.
5.
That freaking was literally the best.
Well, who scored it?
You make sure you show your mom that
I was scared for you.
And then it was like, first three was right there. If you let me
I want to go. I'll let you grab the one. There's a lady walking.
But I wouldn't have known.
Saturday. Saturday. Friday.
Okay. So I told you I would show you how matrices are used in real life, okay? So this would be a matrix. And then this would be another matrix, right? And it's just a way of organizing data where all you have is the numbers, right? It's like a table that's stripped down. That's all a matrix is. It's where you put in data. And then notice, remember we talked about how you only add the things that are in the same place, right? So in row 1, column 1 of these two matrices, we have data from 2003 for businesses. One's for men, one's for women. So if we added those two numbers together, that would be the total businesses in 2003 for both men and women. Do y'all see how that works? So if we add together the loan amounts, it's just that we're just adding the women and the men's totals together for each year. That's all that is. Okay. Now, I told you I was going to make life easy on you today. I'm only going to have you do numbers 1 through 10. Okay? That's it. Just 1 through 10. Yeah, go look in that cup over there. If there's not one, I can get one on the drawer. Yeah.